please get a seat? There are seats around the place. Shh. Hello, everybody. Hello? Hello? Hello, a couple of you are there and awake. Welcome to an exciting Wednesday lecture of COMP1511 18s1. Hope you're as excited as I am. Is the volume for the microphone okay? Is it okay up the back? Good? Cool. So, welcome back to another exciting day of linked lists. I've got the same overview as yesterday. We're just doing more linked list stuff. It'll be great. In terms of the admin, don't panic. Covered that yesterday. Who hasn't started assignment 2 yet? Why did you not start assignment 2 last night? Do you have a very good reason? Do you want to tell the reason, or you can just have a good reason? Like, I'm very serious. The assignment is due on Sunday, and it is currently Wednesday. So like Wednesday, Thursday, Friday, Saturday. That's 5 days. Okay, that is a very small amount of time. Please start the assignment. I mean, you'll fail, and I'll be sad, but you'll be more sad. But just do it. But how are you going on the assignment? How many of you have got something that will win against the bots some of the time? It has won a game before in its history. It's pretty good. It's sort of about half of you. Okay. Shh. The weekline weekly test. One of the weekly tests, it might be week 8 or 9 or 10, I've lost track, is due tonight. I thought it was not due tonight and I got confused. But there is a weekly test due tonight, so you should do it. And once again, there are help sessions on. There is one tonight in J17-201, 6 till 8 p.m. There's one on Thursday in the same place. There's 3 on Friday. Shh. Like, if I talk louder, you shouldn't also talk louder. The point is that I talk and you don't talk. There are 3 on Friday. If you're confused about linked lists, if you're confused about the assignment, if you want help with anything related to the course, head along to those. Okay. I have a quick recap of yesterday written down. This is all of the slides from yesterday. I'm not going to go through them all, but just to remind you, we have linked lists, which are a list made up of a series of nodes. A node is a node struct. It has a data and a pointer to the next node. We can make structs. We can make structs with malloc. We can free them. If we malloc something, we have to free it. A very important difference is the difference between a reference to a node and the node itself. If it's a struct node star current, that's a reference to a node. That's the memory address of a node. It's not a node itself. It's just a way of getting to the node. Versus malloc is a way of actually making a node. There's a diagram I drew. We can go through every element in an array in a list. We call this traversing or traversal, going through every element of a thing. And in an array, I hope you're feeling really good about this by now in the course. While I is less than the array size, array I equals something, I++, this is a way to go through everything in an array. And the same equivalent thing for a loop looks like this. Instead of going from I is like 0 to n, we go while current is not null. So while the current node that we're looking at is not null, while we are still looking at a node. And now for today's content. So this is looking a lot more at that traversal thing that I just had. This is the core of most of the, well, very much of the linked list code you write will be this at its core. So we have something, we make ourselves a struct pointer that will point to the current thing we're looking at. We make that start being the start of a list or whatever we want to start at. While this is not pointing to null, we do something, and then we go current is current next. So we move along to the next one of the list. So if we wanted to calculate how many nodes are in the list, I guess have a think about it for a second. If we go through everything in the list, to count the number of things in the list, we just count like one more per thing that we see, right? And so the code for this works like this. We have our current pointer, it starts at the start of the list, just like before. We have the number of nodes we've counted so far, starts at 0. While current is not null, while there is still another node in the list, increase our counter of nodes, and then go along to the next one. Would you like me to draw a picture for that? A couple of people. Would anybody not like me to draw a picture for that? Did you raise your hand twice? Okay. There was 1 vote for no and 5 votes for yes, so The rest of you are you awake? If you're awake, raise your hand. Okay. Do you just have no opinions about anything? Projector 2. Cool, and the reason that I want to go through this with the diagram is to like make this thing really clear. This is the core of most of what we'll be doing, well, a lot of what we'll be doing from now on. And probably, the people here, you'll be falling into like a couple of categories. There are people who understand linked lists, who are like, Andrew, this is so boring, just shut up. I want to do something interesting. I'm sorry, I'm teaching linked lists still. There are people who are so confused, they're like, I don't know what this is, what's a linked list, what's a struct, what's C. I hope you've learned something over the course thus far. But then there's the people who are a bit confused, but if you think about this stuff, if you sort of not just listen to me ramble and draw pictures, but sort of think for yourself, how does this work? You know, how would the code work? How would I write this? How would I draw this? And those people will, at some point soon, be able to do linked lists. And so it's, you know, mastering this sort of loop here, once you've got this down, you'll be good. And so let's say I have a list. Let's say I record it this time. 3, 2, 1, go. So let's say that I have a list. 3, 1, 4, 1, 5. Points to null. And so this is a list. Each of these circles is a list struct. It has two fields. It has a data field, which is the number, and a struct node star next, which is the pointer or the address of the node that comes after it. And so the picture behind this code would look like this. I have a struct node star called current, so I have an arrow, a thing that can point to a node, not a node itself. And I'm going to say that I also have one of those called list, which points to the start. So I'm going to say current equals list, which means current points to the same node as list does. And then my num nodes is 0. Cool. While current is not null, is current null at the moment? Is current going to be null? What does null mean? Any ideas? Did you draw an X with your arms? Nothing, yes, nothing, exactly. Null is the way that we explicitly say there is nothing here, which is the way that we say this pointer does not point anywhere. Given that the pointer points to the node with a 3 in it, is this pointer null? Does it point to nothing? No, cool, it points to something. Something is not nothing, very good. So current is not null, so we go num nodes plus equals 1. So we're going to turn our 0 into a 1, and then current equals current next. And so this means current is now going to be equal to the value of the next field of the struct that it points to. So we have the two fields of the struct. The 3 is the data field, and then the pointer is the address of whatever that node. So that is the address of that node there. Current equals current arrow next means current is equal to the value of the next field of the node, which is the address of the node after it. So current now points here. And run the loop again. Is current equal to null? No? Very good. So we num nodes plus equals 1 becomes 2. Current equals current next. Current points to the 4. Is current null? No, very good. Becomes 3. Current moves to the 1. Is 1 null? No, it's not. Very good. 4 points to the 5. Is 5 null? Nope. Cool. 5. And then current equals current next. 5 arrow next is null, so current now points to null. Is current null? Yes, it is. Cool. Current is null, therefore current is null. And so we stop. And the reason for this, if we try to get the next field of null, like if we have a thing that's null and we say, get me the next field, it's going to go, what are you doing? That's null is not a struct. Cool. And so this has shown us that the list is 5 long. Cool, we can count. Good work. And so we can do a whole bunch of things like this. We can do all sorts of operations. So rather than counting the nodes in the list, how could we sum the nodes in a list? Who thinks that they might know how to solve this? I'm not going to make you do it or anything, like make you tell me how to do it, but who thinks they might know how to do this? Okay, like 5 of you, maybe 10. So I will jump into the VLab. That one, yeah. I should have copied. Oh, not Vim, Jedit. Cool, here is some list code. Okay, I'll make this into a function. This keyboard is different to usual and the buttons are in a different place. Cool, okay, if I am going to sum a list, like if I'm going to sum all the values in a list, what do I need to have given to me? The list? The list, cool, very good. What is a list going to be? When I say a list, what do I... When I say a list, what do I mean? Yeah, someone said like a pointer to a node. So a list is just a series of nodes which know how to get to the next one. So a list then is just a pointer to the first node. And hopefully you know by now that when I say struct node error, I have a pointer to a node. I'll call it list. Cool, very good. So let's make it do the count list thing first. And so this will be the code from before. Get rid of those new lines. Cool. So if we have a list, this code from before will give us the length of that list. But since it's a function that needs to return something, what am I going to return in order to return the length of the list? Yes, num nodes. Nodes. Cool. So I need to give it a list. Oh, I'll just make a list here. Make node, come on. Cool, and so a list is a pointer to the first node and they'll point to the next ones. So struct node star first node in the list equals make me a node with the value 3. Cool, then to make the next node in the list, it's going to be the first node's next pointer, right? So first arrow next, make node 1. And then how do I get to the next field of the one after this node? Yes, another arrow next, and another arrow next, 3, 1, 4, 1. 5. Next. Cool, and so this will make me a node, and this node points to this one, points to this one, points to this one, so like the picture we drew before. Does this node here, the very last node on the list, does this point to null? Does anybody remember from when we wrote the make node function down here? This will set the next field of our node to null, so it will start out being null, so we know that the next field is null. So this is a list, hopefully. So now let's printf the length of the list is list underscore length. So what am I going to pass this in for the, when I'm passing in the list, what am I going to pass in? Which of the variables? Any ideas? Yes, first, the one and only variable of my function. So I'm giving the list length function this pointer to the first node, and then that points to the second, points to the third, like the picture we had before. The function will then do this typical loop, like list loop structure. So we start out by making a current pointer that points to the first thing in the list. We go until current is not null. So until current is null, we go to the next node in the list and then do something else in between. So in theory, if I can work out how to resize a window. Cool. Is that a good size to read, people at the back? Cool. List.c. Oh man. What have I done wrong in my code? This is not valid C. So let's get rid of those question marks. Cool, let's try again. Oh man, what did I forget? Forgot my function prototype. Where are you, function prototype reminding person? I can't see him, maybe he's not here. Function prototype, yes. Cool, compile. That's fine. Cool, and so this function here, our program calls, it makes a list that's 5 long. It calls the list length function and it prints out the value, the return value. And so it's printed out the length of the list is 5, which is good because it is 5 long. Cool, let's also print out the list just to prove that it's there. Is this print list? I totally had a better one. Cool, okay, so our print list function from yesterday does indeed still print our list. So we can see 31415 null. The length of this list is 5. Cool, is this all good so far? Do you believe me that having 5 nodes added to get like counting to 5 gives us 5? This is all good so far? Cool, so how then would I change this to, instead of giving me the length of the list, give me the sum of the values in the list? So what do I need to change? I've sort of given you a hint. There are these 2 bits here that I need to change. So my int num nodes before stored the count of nodes. So what do I need to store now if I want to store the sum of the nodes? The sum? Cool. I'm giving you the answers. Int sum? Cool. And so then when I go around, rather than num nodes plus equal 1, how do I increase my sum with the value of this list item? I heard sum plus equals, and then something sounded convincing. Yeah, so sum plus equals current error data. And so what this is going to do, this is going to get the data field, so the number out of this current node that we're looking at, and add that to our sum. So is this all good so far? Rather than counting the nodes, rather than increasing my counter by 1, I increase my counter by the data field of the node. Someone said, shouldn't you be not making this mistake that you're making? Yes, indeed. Oh, see, it's even warning me. I'll ignore that. I haven't called my function, so it's not going to do anything. Let's change that. The sum. Cool, so now I am also going to print out the sum of the list below the length of the list. What's wrong? I put a V somewhere. Ah. Did I accidentally delete the first line? Is that better? Okay, I have made a mistake that DCC has conveniently told me about and I'm going to conveniently ignore. So when I run my list program now, what I expect it to do, it should give me the length of the list. So just like before, count up the length of the list. And then afterwards, print out the sum of the list. So add the values of all the nodes together and print that out. Cool, and so the length of the list is 5. The sum of the list is 0. So at this point here, I'm going, my code doesn't do what I think it should do. And now I know some of you have spotted the bug, and DCC's told you what the bug is, but it's very useful to be able to go, I don't know what my code's doing, it shouldn't be doing this, something is wrong, but I don't know what's wrong. And so one of the biggest tools you have for debugging things is to print things out in your program as you go. So in this case, I know that I don't even return a value. How does it work if it doesn't return a value? Shouldn't that be a compiler error? Hang on, I'm just really confused because I didn't think this would compile. Curtis, should this code compile? I don't return from an int function.
No, it should not compile.
It compiled. Okay.
Well, so it depends how aggressive your compiler is. There's technically nothing wrong with that, but some compilers give you encourage will yell.
Yes, okay, so apparently you can just not return anything from your function and it won't complain at you. Shh. I mean, it will complain at you, it'll say it's a warning and you'll be like, nah, I don't believe in warnings. So what do I want to return here? I want to return the sum of my list, right? So return sum. Cool, and now that's the bug that I actually wanted to make. So the length of the list is 5, and the sum of the list is negative this big number. Should the sum of the list be this number? Is this the correct answer if I add together 3, 1, 4, 1, and 5? Yes. No. Yes. What sort of primary school did you go to? Like, did they not teach you this in Australia? Like 3 plus 1, adding numbers together? Like adding 5 single-digit numbers shouldn't give you like a negative. Anyway, so we have found something is going wrong with our code. And some of us know why, but let's pretend we don't know why, and let's pretend that we didn't accidentally forget to return something. So all we know is we're getting the wrong answer. We call this function, we give it an input, it gives us an output, and that output is wrong. And so the best thing we can do, well, one of the good things to do, is to get debugging information by printing things out as you go. So what I would probably do in here is I would say, let's print out what sum is. And then print out what the current node's data field is. Current node data. Cool. And so what this code will do now, while current is not null, so as it goes through each node, it'll add current data to the sum. It'll then print out what the sum is and print out what current data is. I might actually put that in there twice. So print out what the sum is beforehand, add the sum on again, and then say what the sum becomes afterwards. So does this make sense? I'm adding in, so each time I go through the node, like go through each node, I will print out what the sum was before, what value I'm adding to it, and then what the value is I get afterwards. So I know which thing is going wrong where in my code, hopefully. Cool, and so I can see the length of the list is 5, that's all good. Now I'm inside this function here. If I can drag this. Cool, so we can see inside this function here, we start out by printing sum is currently blah. Sum is currently this, okay, that's not right. I then add the thing to the sum. I add 3 to the sum, and I get this number here. This is correct. -8 plus 3 is -5. So the adding on part is going wrong, but the starting out value is wrong. And so when you see some random, like strange, unexpected number in your code, what are you thinking? Yes, uninitialized variable. Say that again louder, everybody. Uninitialized variable. I'm not as persuasive as Jashanka's at that. But on the bright side, I don't yell as loud, so it's, you win some, you lose some. So to initialize my variable, I go int sum equals 0. And now when I compile my program, and I run my program, cool, and we can see the sum of the list is 14. So 3 plus 1, 4, 8, 9, 10, 11, 12, 13, 14. Cool, so it has given us the right answer. We can now get rid of all this debugging stuff. I recommend when you're doing things like assignments and labs and stuff, leave it in but comment it out, and then when you're finished, delete it all and submit it. Because that means that if you delete the printfs and then later on you have another bug, you've got to write them all out again. So comment them out for now and delete them when your program works overall. I'm giving you guys some great life advice here and you're just ignoring me, so. Cool, and we can see it's done what we wanted. The length of the list is 5, the sum of the list is 14. Cool, is this all good? Are there any questions about this? Okay, so let's look at the next thing. Cool, I do have a slide for this thing as well. So, an important thing we need to do with lists is to add. An important thing that we need to do with lists is to add new nodes to our list. Like, we can't make a list if we can't add new things to it. And so there are 3 places that we can add things. We can add them at the start, at the end, or in the middle. So at the start being before the first node in the list, at the end being after the last node in the list, and in the middle being anywhere else apart from before the first or after the last. And so let's write some functions to do these. Let's write some code to do these. There we go. Is the font size, if I make the font size for this one smaller, is it going to be too small? Is this font size still good? Cool. Okay, and so let's write some functions to insert nodes. So let's start with inserting a node at the start of the list. If I want to insert a node at the start of the list, let's make a function to do it. So if I'm going to insert at the start of the list, I need to have a list to insert it into. Think about what it's going to return. We'll get to that at the end. But to insert a node at the start of a list, and I'll draw a picture for this. This one. Cool. So let's chuck that down there. To insert something at the start of my list. So back to before, right? We have our list. We have the list, the struct node star called list that points to the first thing in the list. So conceptually, if I want to make, like, to put a new node into this list, in terms of not code, but in terms of drawing on paper, what do I need to do? I'll give you a clue. The first step is I need to actually make a new node. So I need to actually draw a circle and put a number in. I'll give it a 5. Cool. And so then to add this to the start of my list, what am I going to have to do? Because remember, a list is a thing where the nodes all point to the node after them. So if this is the new start node, what should the next node after this one be? Yes, the old start node. Perfect. So I want to make my new node, my node with a 5 in it, have its next node be this 3. And then where's the start of the list going to be now? Where is the start of this list? It's now this new node here, right? Cool. So we want to make a new node. We'll call it new because we can. put a value into it, and then make its next thing be the previous start of the list. So to put it in front of the current list, we put it in front of, like make a new node, and then its next node becomes the first node from before. And then the start of our list is now the new node that we've got here. And so looking at coding this up, we take in a list. I'll kind of draw the steps. So the step 1 was make a new node. Step 2 was make it point to the start of the existing list. And then step 3 was that is now our new list. Cool, so let's start with step number 1. How do I make a new node? I'll give you a clue. It's the words new node and then another word afterwards that starts with F, ends with function. The new node function? I tried. So if I want to make a new node with the value 5, I call new node, give it the value 5. This will malloc me some memory and give me back a blob of memory with a 5 in it. And so I need a struct node star, I'll call it new, equals new node 5. So this will contain the address of this new node here that we have been given by malloc. Cool. How do I make this point to the start of the existing list? What do I mean by make it point somewhere? Which part of the node am I going to be changing? Yeah, the next thing. So new arrow next is the next field of the struct, the thing that says where the node after it is. And so if I want this to be equal to the address of the previous start of the list, the current list, how do I do that? Yep, new arrow next equals list. And so this is saying make the next pointer of this point to the node that we currently have pointed to by the list. So that means make its next pointer here point to this node that was currently pointed to by list. And so our new list is now that node. And so what do we want to be returning from our function? If we've inserted a node at the start of a list, we want to give the list back, right? So I'll make it be a struct node star. And so if we want to give it the list back, what is the start of our list now? Yep, new. The pointer called new is the start of our list now. So if I return new like this, I'm going make me a new node, so draw a circle on the page, put a 5 inside. Make it point to the start of the existing list, so make its next pointer point to the current list that we had. And then our new list is now this node, so we return this saying this is now the start of your list. Cool. Does that make sense so far? Yes? No? Who is confused but doesn't want me to ask them if they have a question? They're just confused and want to express confusion but not have me say anything to them at all. Okay. A few of you. Who is not confused? Everybody else, what are you? Are you not paying attention? Are you sleeping? So let's call this code to make ourselves a list. I'm going to move this really gross code somewhere else. Maybe I'll save it as this one.c. Cool. And so let's get rid of this. Actually, let's not do that. Does Control-Z not work? Have I broken something? I am confused. Okay, that's fine. We'll use that button. So, cool. Before, we made a list that went 3, 1, 4, 1, 5 by going make node 3, make node 1, 4, 1, 5. If we wanted to call our insert start function that I'm not going to forget a prototype for, except that control is broken. You can copy and paste without a keyboard, right? Do I have caps lock on? I do. Huh. So if you find you can't copy and paste things, Check if you have caps lock on, because if you do, then anyway, cool. Mystery solved. So my insert start node will insert at the start of a list. So if I have my existing 31415 list here, and I want to insert in the start of this list, so if I wanted to add a 5 to the start of this list here, where did my function go? I'm now in the wrong file. Okay. I understand now. Cool. I'm in the right file now. Okay, so if in my thing here, if I want to insert a new node at the start of my list, I need to give it my existing list, which is first. Cool. And so what I'm doing here, I'm calling this insert start function on my list that currently existed with the 31415. And so now if I print out my list, it should be giving me like a different result, right? It should be printing out the list with the 5 in front, and the length and the sum should be different. I say should be in the way that, oh, maybe I have a mistake. Ah, it's called make node, not new node. Ah, compiling the wrong file. Cool. And so I said before, I've got my previous thing that prints all this stuff out. I then, I call my insert start function to add a new node to the start of the list, giving it my list, and this should have added a 5 at the start. And then when I print it out, it should have printed out with the 5 in front, but it didn't. Why is the 5 not in front of my list here? If you have a look at what I've done, I've called the insert start function, giving it my list. But I haven't done anything with the return value of this function. What does this function return? It returns the list, right? It returns the start of the new list. So I need to update my list. I need to say first equals insert start first. And what this means is, I have my list. I give it in, it's called first here. So first is a pointer to the 3 in the nodes 31415. I then make 5 be the new start, but I need to update my existing start to point to this new start, right? So my function returns the address of this new node here, and I have to update my existing start node, or my existing pointer, to point to this new start node here, like this. And now I do actually point to the start of the list. And so saying first equals insert start first means my new first is going to be the pointer that this returns, the address that this returns. Hopefully. Cool, and so we can see 31415, is all good. And now I've added the 5 in front successfully. The length of the list is 6, the sum of the list is now 19. Cool. Does this all good so far? We've added a new node to our list. Let's move on to list 2. But could I, rather than doing this here, could I just make an entirely new list from scratch? So rather than hard coding all these things in, could I call my insert start function to just add at the start over and over and over again? So let's do that. Let's write some code. So I want to scan in a number and then add that number to the start of the list that I have, and then keep on doing that over and over again. I will delete all that. Cool, and so let's do a loop like we had yesterday. While scanf number. Let's try that again. Equals 1. Cool, and so what this is going to do, I have an int called number, I store a number in it, I'm going to scan a number into that, and then I'm going to add that number to the start of the list. So the new start of my list is going to be this number here. Node star struct. I'm going to start this out as null because it doesn't point anywhere, like it explicitly does not point anywhere. I am then going to go like I had before. My list is going to be now point to the thing that I get back from this insert start function that I give the start of the list. Cool. So in theory, get rid of that one, and I'll change those to be list. Cool, hopefully that didn't break anything. I compiled. Cool, and so if I type in numbers 1, 2, 3, 4, 5, 6, 7, 8, and then I print out my list, I have 5, 5, 5, 5, 5, 5, 5, 5. I did not actually type in 5 that many times. So what's happened here? Why has my list just given me 5s rather than the numbers that I put in? If I'm scanning my number into this variable number, and then I don't give anything to my insert start function that's a value, it's just going to not put in, right? Like it's hard-coded down here to make it be equal to 5. So I need to give it a number, int value. And so I give it, make the node have this value in it. I'll give this the value which is number. I will change my prototype, not going to forget. Cool. And let's print it out as we go so that we can see it's happening. This one. Cool. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we can see it's adding the numbers, and it's always adding the new number to the start of the list. So it's adding them in like reverse order effectively. When we add in 1 through to 10, we get a list that's 10 through to 1. Cool. Is this all good thus far? Are there any questions thus far? Who's still paying attention? Okay. People who aren't paying attention, is it because you have better things to do or because I'm boring? Like, is there anything I can do to make you pay attention, or are you just not going to pay attention no matter what? I suspect no one's going to answer that. So, are there any questions? Did someone have a question? Yes? Can I go through the insert start function again? Yes, I can. So, I'll make this bigger. So I call it up here. I say insert start, giving it some list and giving it a number to insert. And so I give it the pointer to the start of the existing list and then the number to put into the new node that it makes. And so I make a new node for a start. I'll redraw this diagram here again. So currently the first thing in my list is this 3. And so the struct node start list points to this node with a 3 in it. I then make a new node. So I draw on the paper a new node. I put the value into it, so if I give it 10, it'll put a 10 in there. The next step is to make this new node point to the start of the existing list. And so this one here, like if we want to add it to the start of our list, we need to put it before the things and then join it to the rest of them. So that's that step there, making it point to the start of the existing list. And then finally, this is now the start of our existing list. We've added something new to the front. So we want to make this here be our new start of the list. So we return new, we return the address of this node here. And then we say in here list equals this. So we're giving it in this list pointer. Inside the function, it's going to make the list, add a new node to the start of that. And then we're updating in the main function, list is now going to point to here. Does that make sense? Cool. Are there any more questions? Okay, so let's have a break for approximately 10 minutes. Okay, hello again. Sorry for the delay. Some things broke. Hopefully they're not broken now. I noticed that I had like I had only 2 people ask me questions during the break, and I normally have like 20. So, are you okay? Are you sleeping? Are you like so confused that you don't have any questions, or maybe you're just busy working on your assignment, ignoring me? Fair enough. Actually, thinking of ignoring me because you're bored, I have a puzzle. I was going to put a slide in, I forgot to put a slide in. So, you know how, and so if you're sitting there bored thinking, this is boring, I want something hard to do, this is a fun, like, challenging puzzle. If you're sitting there confused, then don't stress about being able to do this. This one. So you know how the lists that we have so far, right, we have like some numbers, and then it points to null, right? What if I had a list where instead of the 5 pointing to null, pointed back to the 1? How would I write a program to tell that this has happened? So how would I write a program that would go either this list has a loop or this list terminates? So if you're bored, that's something fun to think about. Does this list end? And if you're not bored, then you can keep learning things. So, yeah, I know that's a fun puzzle. I have spent a lot of time thinking about that. So having inserted at the start, let's insert at the end. So I think there are some people who have like the first hour clashing. So if you weren't here for the first half, we inserted things at the start of a list. Now we're going to insert things at the end of a list. Save as list 3. Cool. So to insert at the end of a list. At the end. Oh, I do want to draw a diagram. This one. Cool. So if I wanted to insert at the end of a list, hang on. Is the volume okay still? Still good? Too quiet? Oh, it's too good. So if we want to insert at the end of a list, right? Before we had, here's our list 3, and we inserted at the start by making a new node and making it point to the start of the list, right? So this is all good. We can make add something to the start by making the new node point to the previous, like the existing list. But if I wanted to add it to the end of the list, what do I have to do there? Like, what are the steps I have to do there? Step 1 is still going to be make a new node, right? If I want to add 5 to the end of the list, I make a new node with a 5 in it. But then rather than making it point to the start of the existing list, what do I need to do to my existing list to make this one be in the end? Yeah, exactly. Make the 3's next point to 5. So currently the 3 is pointing to null. Make it point to 5 instead. So make end of existing list point to new node. And then do I have to do a step 3 here? Is our new list now that node? No, our list is still the same as it was before. This is still our list. So I think there's probably just those 2 steps. Since we're not changing the start of the list, we don't have to return anything, so make that be a void. Cool, and we want to give it the list and the value to insert. Awesome. So it's not quite that simple, unfortunately. To make the end of the existing list point to the new node, we need to find the end of the existing list, right? And so let's make this problem easier by making a function. So we'll say we have some function that gives us the last node of our list. And so this function here will return a pointer to this 3 here. If we gave it this list before we'd done this bit, it would give us a pointer to the node 3. So given that I have a pointer to the last node called last, how do I make this point to the new node? So I want to change last arrow next or last arrow data? Last arrow next. I want to take this 3 here, I want to make its next field point to this node with a 5, right? To add the 5 to the end of the list, I take the current last one of the list should point to the new node that I'm adding. So last arrow next equals new. So what this is going to say, the next pointer from last should point to new, so should have the memory address of this new node that we've just made here. That was new, that was last. Cool, and so now we're done. We've added 5 to the end of the list. Is this all good so far? And then the next challenge, I guess, is to make a function to find the last node of the list. So this is going to take in a struct node start list. What should this return? If we want it to give us a pointer to the last node in the list, we want to return some sort of pointer. Yes, struct node pointer. Struct node star last node. Cool. And so this one here should return a pointer to the last node in the list. This is how I write like a variable called list. Okay, so to return a pointer to the last node in the list, what do we need to do? That's sort of a badly explained question. The answer is we need to find the last node in the list. I don't know how I could have asked a question that would have made that make sense. But how do we find the last node in a list? We can't, like with an array, right, we can go like array index 5 straight away. With a list, we can't go straight away to array index 5 because like we've got to go one thing after the other. But if we want to find the end of a list, I'll make a new list down here. 1, 2, 3. Because all we have is the start of the list. Like the only thing we know about is the start of our list. And then the first node can get to the next and so on and so on. So we're going to need to look for the last node, right? And so we can look for it by going, is this node the last node? If it is, we found the last node. If it's not, then keep going until we find the last node. So not in terms of code, but in terms of drawing, right? We want to go, current is looking at this one. Is this one the last node? No, it's not. So current is going to look at current next, so 2. Is 2 the last node? No, cool. Current's looking at 3. Is 3 the last node? Yes, it is. How do we know that 3 is the last node? Yep, exactly. 3 points to null. 3, the one after 3 is null. So we know that if this node's next is null, this is the last node in the list. Right? If current arrow next is null, current is the last node in the list. Cool. So does that make sense? If current arrow next is null, if we're looking at the 3, and 3's next is null, this is the last node in the list. And so aside from this one little thing here, we otherwise can just copy our pattern that we have here. And like I said, the structure of our list operations is a loop, it's a very similar loop the rest of the time. We don't want to sum or the number of nodes, so that's all good. So when we go, if current next is null, we're up to the last node on the list. We want to loop until we get to the last node. We don't care about summing things. Current is current next. So if we look at this loop without changing the condition, so just looking at this right now, we're going to go while current is not null. So current is going to be looking at 1, then it'll go to 2, then it'll go to 3, then it'll go to null, and then because it is null, it'll stop. And so then after this loop, at this point here in the code, what do we know? There is sort of one fact that we know 100% for sure. When our loop has finished, like at this point right after the loop, we know that this condition is not true. So in this case, at this point in the loop, we know for sure that current is going to be null. Like the opposite of this condition here is guaranteed to be true as soon as we're out of the loop, assuming we haven't done anything silly like break or whatever. I'll say that again because one of the tutors said yesterday, oh, I didn't even realize this until Andrew Taylor said it. When you're immediately after your loop, you are guaranteed that your loop condition, like the opposite of it, is true. So at this point, we know current is null. If we returned current just like this, so if we didn't change this condition and just had this, we'd just be returning null, right? And so we'd be saying, here's the last node of the list, it's null, but we've gone off the end of the list, so that's not useful. So instead we say, well, current next is not null. And so what this is saying is, keep going through the nodes until we get to the node where current arrow next is null. And the node that points to null is going to be the last node on the list. And so this will give us the last node in the list. Instead of returning sum, I want to return current. So does this make sense? I want to loop through my current pointer, make my current pointer point to the next node and so on, until it points to the very last node, and then return that pointer. So this is the address of the last node. This is how you get to the last node. Cool. Does that make sense? Are there any questions about this so far? Cool. So we're done. We've finished this function. To insert at the end, we make a new node. We find the last node, and we make the one after the last nodes be the new node. That was easy. I always get surprised when I'm writing code, and so then I call a function in my code, then I go and write the function, and it's like, oh, now my code's just finished. Cool. So in theory, this will do what we want. Let's save this as list 4. Ooh. Okay. Save it as list 5. So rather than inserting at the start, let's call insert end to insert at the end, hopefully. And so this code then looking kind of from the top, while scanf%d is equal to 1, while we do scan in a number, while we're given a number, insert this node at the end of the list. This returns void, so it returns nothing, so I'm going to delete that there. So insert this number at the end of the list, and then print the list out. Cool. And so then our insert end function makes a new node, and then finds the last node of the existing list, and makes that node point to the new node. And then returns nothing because we haven't changed the start or anything like that. So in theory, list 5.c. Did I forget a function prototype again? I was going so well. I think the trick here is to write your prototype before you write the function, and then you won't forget. I forgot another function prototype. If only there was like a program that could find function prototypes for me and make them in my code. It'd be so great. Cool. List. So, what did I do wrong? Something bad has happened here. It's all red and yelling at me. Member access with a null pointer of type struct node. So what have I tried to do? Like, what has happened here? What does it mean by member access with a null pointer of type struct node? Let's look specifically at this word here. It means that I've got a null pointer, and I'm trying to dereference this null pointer. I'm trying to take this null pointer and go, okay, do something with this. And it's going, you can't do that. And so, where were we? Last node. So this is saying current is going to be equal to list. And then while current next is not null, current is current next. But this is problematic because if current is null, then like current next, you can't get null arrow next, right? And so this is where things can go wrong. Like if our list is empty, an empty list would look like, instead of a pointer to a node, we have a null pointer, right? There is no list, it just points to null, points nowhere. And we need to do something about that. And sort of along the same lines, it's really important to document your functions. Sorry, this feels like I've just thrown things in that are unrelated. I promise it's related. It's important to like document what your functions do. So what your functions assume, what the caller should do. So for example, with this function here, it returns a pointer to the last node in the list. If we give this null, if we don't give this a list, what should it return? We don't know, right? Like the person making this function has to sort of decide this function should do this. If the list we're given is null, then as we've seen, bad things will happen. And if the list is null, like what can we return? We don't have any nodes to return, right? So we could just say returns null if given an empty list. Cool. And so if this points to null, if instead of pointing to a list it just points to null, like this, then this means that our list is empty. There's nothing in there. And so we'll just return null. Like that. And so this is sort of saying we can't do anything, so we're going to say, hey, we're returning null because the list was empty. And so now it's the responsibility of the person calling this function to decide what they're going to do about that. And so we did that in insert end here. So at this point here, we're calling last node, and last node has said, if you're going to give me an empty list, I'm going to give you back an empty list. I'm not going to do anything for that. So in our insert end function, then we need to do something about, like, if the list is empty, then don't do this, right? So how will we do that? If we're inserting at the end of an empty list, what does that mean? What does that look like? If our list is just points to null, is there a difference between inserting at the end and the front and the middle if it's just an empty list? There's not, right? Like, we can only insert in one place, which is the list. So inserting into an empty list then, we'd just go, okay, make a new node and make a list point to that node. Cool. So what would that look like in here? If last is null, then what are we going to do? We've sort of got a problem here. If we're being told to insert into the end of an empty list, again, we'd have to, like, inserting into the end of an empty list would mean making a new list, like making a node, here is your list, here is, go forth and do things with it. But we've got a problem here because we've got a void function, so we can't make a new list in here. We can't, like, go, here's the start of a new list, go forth and give a new list. So we've sort of got two choices. We can either handle it in here, we can say, okay, if our list is empty, then make a new list, otherwise add it to the end of the list. Or we can do something here to change this so that rather than doing nothing, it will return a new list if we have to make a new list. I guess there are pros and cons either way, but I reckon let's do it this way. If the list is null, if we have an empty list, let's try that again. Then we're just going to say list equals new node number. Right. So if the list is, if we don't have a list yet, then make our list be a new node. And otherwise, if it's not a null, like if we do have a list, then insert this at the end of the list. Cool. And so what this will do, if the list is empty, it'll just make a new node. Otherwise, it'll insert it at the end of the list, and then it will print out the list. So in theory, this will work. Oh man. It's called make node, isn't it? Yes, it compiled. I'll put that up here. Cool. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Woohoo! It adds things to the end of the list. I should type Control-D so that it actually exits properly, shouldn't I? Cool. And so now we've made two functions or two programs. One that will insert at the start of the list, and one that will insert at the end of the list. Let's save this as inserted end. Let's also save a version called insert. That was not the right button. So it's start. Cool. And so I'll just change this one here. First equals insert start. So this is just back to the code that it was before when it inserted at the start. Just so that I can have two different programs compiled and show the differences between them. Cool. Start.c. list end list 5, and so end.c. Cool. And so just to show you, list start doesn't have the print list inside the list. Oh well, neither did, that's fine. I'll move that now. So end. Cool, that one does put the list inside. Let's try that again. List start, cool. So as promised, it inserts at the start of the list, and list end will insert at the end of a list. Cool, and so we have, cool. There's a Linux program or tool utility called seq, S-E-Q, which will generate sequences. So if I want to generate the numbers between 1 and 100, I can just type seq 100, and it'll print me out the numbers from 1 to 100. And so I'm going to use this to put lots of numbers into my code. So I'll get this to generate me a list with 100 elements in it. I don't know if I've talked about this before, redirection with pipe. Have you seen like piping in terminals? No, cool, okay. You can learn something today. So you know how when we run a program, we can go like /program and then the this way arrow and some file.txt, and that will take the input from file.txt and give it to the standard in of your program. We can do a sort of similar thing where we have the pipe operator. So we say some program pipe in list start. And so this means that the standard in for our program will come from the output of this program. So whatever this program does on standard out, we'll go to this program on standard in. So we can sort of like chain commands together. Cool, and so we can see it did this. Let's make it even bigger. Let's go 1,000. Let's get rid of the print list thing because that's going to slow it down. Cool. I do have a plan, trust me. Cool. So my insert at start of list function, given 1,000 things, will give me 1,000 numbers. Let's do 10,000. Cool. So this has printed out a list with 10,000 numbers, and at the very start is going to be 10,000. At the very end is 1. It's 10,000 long, and the sum of it is 500,500. That's cool. So then let's do the same thing, but inserting into our list end function. So interestingly, this is quite a bit slower, right? Maybe it doesn't feel much slower. Let's make the number even bigger. So to insert 100,000 things, maybe this is going to be too slow. Is this going to take longer than I hope?
You know how exponential numbers work?
It's not, it's polynomial. Okay, that number was too big. Let's try a smaller number.
That's still going to be quite big.
Let's try an even smaller number. Cool, there we go. So we can see printing out, adding 20,000 things to our list takes a reasonable period of time. If I add 20,000 things to the start of my list, will it also be slow or will it not be slow? So let's have a vote of hands. Who thinks that adding to the start of the list will also be slow? Who thinks that adding to the start of the list will not be slow? Who has absolutely no idea what's going on? That's about 50-50. That's pretty good. So I hope that adding it to the start of the list will be faster. And indeed it is. Bam, it's done. Bam, it's done. I reckon I can do 200,000 things. Instantaneous, except printing them out takes a long time. And then I can't fit a big enough number because the sum is too big. Make it 100,000 things. Still too big, whatever. But you can see it prints them all out, right? It instantly goes through and prints everything out. Whereas if we ran it with the list end, And for fun, let's do that and leave that going in the background and then come back to it later on. But this is not instant, right? And so let's think about why this might be. Cool. So looking at our insert, I'll make a list for a start. Looking at our insert start function. This makes a new node. Cool, here's a new node. It makes this node point to the start of the list. Cool, so it points to that, and then it returns this node, and bam, that's inserted into our list. So that's like, 1, 2, 3 things done, all the work we need to do. Inserting into the end of the list, step 1 is the same, make a node. I'll put it over this side. But then we have to find the last node in our list. And finding the last node in our list goes like this. Here is our current node. Is this the last one? Nope. Is this the last one? Nope. Is this the last one? Yes, it is, inserted after this one here. And so the 3 would point to the 5 there. And then when I insert the next node, I have to go, is this the last one? Nope. Is this the last one? Nope, nope, nope. Yes, this one's now the last one, and so on. So you see, when I have 10,000 nodes, to insert at the end, to find the last one, I have to go through the 10,000 nodes to find the last one, right? And so that is quite slow. So how could we avoid having to do that? Is there any way that we can make it faster to find the last node? Yeah, someone said we can keep track of the last node. Using just our list, we can't find the last node any faster because we have to go through each thing every time. But we can avoid actually looking for the last node, just keeping track of what the last node was, and then rather than calling our last node function again, reuse that value as the next last one, if that makes sense. So I'll call this insert end fast. So rather than finding the last node, I need to know what the last node is. And this is also called insert start. Let's call this list 6. So instead of finding the last node here, I basically need to have some way of knowing where the last node was. So let's grab this code we had here. Cool. So then what this function here is doing, this function finds the last node and then inserts it after that node, right? And so this would have been the equivalent of this code here. That did not go well. So the equivalent code from the function was make a new node and then find the last node by going through everything again and make that one point to the next one. But we want to, rather than finding the new last one each time, we can just keep track of what the last one is. And then when we do this, right, when we say last arrow next equals new, so when we've added the 5 onto the 3, the 5 is now the new last node, right? So we know where the last node is. And so we'll make that one be null for a start. So let's call it last. Let's name the function called last. So when we start out with an empty list and then we add one single node to the list, what is the last node in our list? So if our list just looks like this, what is the last node in this list? 1, right? The only node is the last node, right? So then our last node is going to be this node that we've just added. Otherwise, to insert at the end, rather than calling our last node function here, we can just keep track of what the last node is. So we still need to make a new node, which we can do here. But then rather than calling our last node function to find the last one, we can just use this last that we've kept track of and make its next point to new. And so this is just using this one here, so it doesn't have to call the function to find the last one. But then how do I update what the last node is? Right, so when I've inserted this 5 here, into this list we had before. What is 5? Sorry, I gave it away. What is the last node now? It's the 5 we've just added, right? So the new last node is going to be the new node that we've just added. Does that make sense? So when we were at this point here, when we just had the 3, the last would have been 3. We then went, the one after the last node is 5, so last arrow next is this new node 5. But then 5 is our new last node, so we want to make a last point to the 5. Cool. Is that all good? I will save that as insert and fast. Cool. Are there any questions about this? Cool. And so I said that on that slide, if you remember before, we can insert at the start, the end, and the middle. So let's do some middle inserting. I'll go back to the slide to prove it. Insert something in the middle. So we've done start, we've done end. Now we should do middle. So let's get rid of this code. Let's grab that other code, insert start. This code was much nicer. Oh. Cool. So rather than inserting in the start, let's insert in the middle somewhere. Probably the easiest way to do that for now is to just insert, make a list by inserting nodes at the start, and then ourselves put one in the middle somewhere to make it easier. No, I'll draw a picture, and then we'll just write a function for it. So getting rid of all this stuff here. Is this recording? This is not recording. Oh my god. Now it's recording. Cool. So this is our list here, right? We've been adding things into our list. So when this loop is finished, we will have a list that we've made by scanning things in. Hopefully that's all good. And so we inserted things at the start by putting the node in here, making it be the new start. We inserted at the end by putting it after here, and the 5 there. But to put it in the middle somewhere, how would we go about doing that? If I want to put this 5 in between and the 1 and the 2, right? So just thinking in terms of the pictures for now, what are the steps I have to do? I have to make this one here and this one here, right? So rather than having, I'll undo that again so you can see it again. Rather than having 1 point to 2, I want to make 1 point to 5 and then 5 point to 2. Cool. Conceptually, does this make sense? I just change where the arrows point to. And so now the list goes 1, 5, 2, 3 because I just chucked 5 in the middle. All good? And then in terms of actually coding that, if we have a list that looks like 1 points to 5, points to 2, points to 3, sorry, without the 5. Let's make ourselves a node. Cool, so we have our list 1, 2, 3 like I have here. And then if we want to add the 5 in between, so 1 points to 2 points to 5, no, 1 to 5, to 2 to 3, to null. So in order to do this, right, we need to make 1 point to 5 and then make 5 point to 2. Yep, do you believe me that that's what we have to do? We have to make 1's next should be 5 rather than 2, and then 5's next should be 2. So let's go struct node star 5 equals new node 5. So this line of code here has made the node for us. Make a node. Cool. So then next up we need to make 1 point to 5. Yep, we need to make the node at 1 point to this new node we've made here 5. Cool. Cool. So that would be, if our first node is called first, we'd be going not like that. We'd be going down here, first arrow next equals 5. And so we've done this here. We had this here like this. We had 1 points to 2. And now we've said instead 1 points to 5. Cool, and now I need to make 5 point to 2. 5.22. How do I do this? Like, in paper I just draw an arrow, right? Cool, I've drawn an arrow, life is good. The syntax would be something like, 5 arrow next equals the node at 2, but how do I get to that node? How would I have gotten to that node before, when it looked like this? So when I just had 1 arrow, 2 arrow, 3. I can get to this one here by going, this is first arrow next, right? But if I make first point to the 5 instead, then I've lost this 2. This 2 is just lost forever. We don't have any way of keeping track of it now. So instead, we need to sort of have a backup, or otherwise do the reverse order. So let's do it this way. So if I'm looking at this one here, so before I change 1 pointing to 5, how do I get to this 2 here? This is first arrow next, right? So what syntax would I use to make this 5 here point to the 2? I want to go 5 arrow next equals something. What's the something? How do I get to this node 2? Yep, someone said first arrow next, right? And so remember first, we have this variable first, which points to this first node here. And then we can get to the node here by going first arrow next. And so by saying 5 arrow next equals first arrow next, we're saying make 5 point to 2. And now if we say make the first node point to 5, first arrow next equals 5. We've done this step here. And so now we've made our list go 1, 5, 2, 3, null. Does that make sense? We'll then print out our list, just to prove we can. Cool. Looking back at this, we can see the one from before took 45 seconds, and then it crashed because it got to counting to too many. So 45 seconds just to do 100,000. Very long. Okay, what have I got wrong here? Since I keep calling it new node, I'm going to make it actually be called new node. Let's see if that fixes it. Oh, it worked. That did not do what I wanted it to do. I'm giving it list. It's actually called first. That would explain my problem. Cool. Excellent. So we see up here, we start out by going struct node star first equals new node 1. So we've made the 1. We've made first next be 2, first next be 3. So we've made a list 1, 2, 3. We've printed out the length, which is 3, and the sum, which is 6. We've then down here inserted the 5 between the 1 and the 2. So we've made ourselves a new node with 5 in it. We've then gone 5 arrow next equals first arrow next. So we've made 5's next field here point to where 1 was originally pointing to next. After that, we've then made the first node point to 5 down here. And then we're done. So now when we print out a list, it has 1, 5, 2, 3. 1, 5, 2, 3. Cool. Does that make sense? Yep. Cool. So the question was, what happens if we get 5 to point to 2, but we don't get 1 to point to 5? So do you mean if we have this? Yep. So what do we do if we have 1 pointing, so 1, 2, 3, but then also 5, 2, 3? The answer is we just have 2 lists, one which goes 1, 2, 3, and one which goes 5, 2, 3. We wouldn't really call this a list now, because lists are sort of like one-dimensional, one string. But we can definitely do this. I will say this as 1. So if we don't have this line of code here, if we don't have that line of code there that makes 1 point to 5, we run our list program. This is all good. We have the list 1, 2, 3, x, and then the list is unchanged because when we print the list, we're printing the list that's starting from this 1 here. We could print the list starting from 5. So rather than giving our print list function the list or the pointer to the node first, we can give it the pointer to the node 5. Right, and so this is done, the first time it's gone through, that's all the same, this is all the same. But then this time here, we've told it to print, and we've given it the address of this node 5, and we've said this is the start of the list. Right, and so now it thinks it's got a list that just goes 5, 2, 3, x. Does that make sense? So it's perfectly valid. The list, like the 5, 2, 3, the 5 doesn't know that there's also the 1 pointing to the 2. Like there's no way that it can know, oh, something else also points here. But we do have the rule that things like each node can only point to one other node. So we can get this sort of crazy chain structure here, but we can only have sort of one path, if that makes sense. Cool. Good question. Are there any other questions?